You ever have that feeling? Your app's running perfectly locally, right? Humming along in its Docker container. But then you think about actually deploying it, pushing it out to the world. Suddenly you're thinking servers, scaling, security, all that complex infrastructure stuff. Feels like a huge hurdle. Well, today we're going to try and smooth that path for you. We're diving deep into getting your MEVN stack application, that's MongoDB, Express.js, Vue.js, Node.js, out of that local Docker setup and onto AWS, Amazon Web Services.
Yeah, and this is really important stuff. We're basically going to walk through the key ideas from Chapter 15 of Bhargav Bachina's book, Ultimate Full Stack Web Development with MEVN. It's all about using cloud services, AWS specifically, for those containerized apps you're building.
Yeah.
We want to make that leap from local development to a real cloud deployment feel, well, less daunting, more accessible for you.
Exactly. Our mission here is to pull out the absolute essentials, maybe some surprising details, and give you practical insights so you feel more confident tackling your own cloud deployments. All right, so AWS. It's everywhere in the cloud space. But why? What makes it such a big deal, especially for deploying something like our MEVN stack?
Well, it's hard to overstate how much AWS changed things back when it launched in, 2006. Before that, if you wanted to host a serious web app, you were probably buying servers, managing hardware, or paying a lot for data center space.
Right, the old way. Expensive and slow.
Exactly. AWS just democratized all of that. It made enterprise-level infrastructure available to basically anyone. I mean, suddenly a couple of people in a garage could access the same kind of reliable, scalable tech as a giant corporation. That was revolutionary. And today it's massive, over 200 different services running in data centers all over the world. It takes away so much of that physical infrastructure headache.
Okay, so it removed a huge barrier. What about its actual strengths? Why pick it for MEVN?
Good question. 3 things really stand out. First, it's just incredibly versatile. You can run simple websites, mobile backends, complex games, big data jobs. It also powers a lot of the AI, ML, and IoT stuff you hear about.
So it covers a lot of ground.
It really does.
Yeah.
Second is the cost model, that pay-as-you-go approach. You only pay for the compute time, the storage, the data transfer you actually use. No big upfront investment. This makes it affordable for startups, small businesses, everyone really. It kind of levels the playing field.
That's huge, yeah. Access to power without breaking the bank.
Definitely. And third, its global footprint and reliability are just top-notch. They have infrastructure all over the planet, multiple availability zones within regions. This means your app can be close to your users. It stays up even if one part fails. It's built for high availability and fault tolerance.
Okay, that makes sense. Reliability, cost, flexibility. Sounds like a massive toolbox, though. You mentioned over 200 services. If someone's just starting, what are the fundamental pieces they should know about first?
Yeah, you don't need to know all 200. The source breaks it down nicely. Think about core categories. For compute running your code, you have Amazon EC2. Those are your basic virtual servers in the cloud. Very flexible. Or if you don't want to manage servers at all, there's AWS Lambda. You just upload your code and it runs. Serverless, they call it.
Okay, EC2 for servers, Lambda for serverless code. Got it. What about storing data?
For storage, the big one is AWS S3. Simple storage service. It's like an infinitely scalable place to put files, images, backups, website assets, anything. And then you have specialized databases. Amazon RDS handles relational databases for you like PostgreSQL or MySQL. And for NoSQL, there's Amazon DynamoDB, super fast, great for apps needing low latency.
Right, so different storage for different needs. Makes sense.
Exactly. Then there's networking. Amazon VPC lets you create your own private network space within AWS, isolated from others.
Yeah.
And Amazon CloudFront is their CDN content delivery network. It speeds up delivery of your website or app to users globally.
Faster load times, better security.
Precisely. And finally, for developer tools, things like AWS Code Build help you compile code and run tests. AWS Code Deploy automates deploying your application. They even have services for machine learning, like SageMaker. The key is, all these services are designed to work together, but you can also just use the ones you need. It's very modular.
Wow, it really is a comprehensive suite, thinking about having all those specialized tools just available, ready to use. You can see how that lets you, the developer, focus more on your actual application features, right? Instead of wrestling with infrastructure setup, it must really speed things up.
Absolutely. That's a core benefit, faster innovation cycles.
Okay, so AWS is powerful, versatile, but how does someone new actually start using it? What's the entry point?
It's actually pretty straightforward to get going. The first step is just creating an AWS account. You go to the main AWS website, hit create an AWS account, fill in your details. You will need to provide billing info because of that pay-as-you-go model.
Makes sense. You pay for what you use.
Right. Once you're in, the main place you'll likely interact is the AWS Management Console. It's a web-based interface, kind of like a dashboard for everything AWS. You can find services, configure them, launch resources, monitor your spending, check the health of your applications. It's pretty user-friendly, organized by service category. You can even customize it.
So a point-and-click interface for managing everything.
Exactly. And for new users, something really valuable is the AWS free tier. This gives you a certain amount of popular services for free for your first 12 months. Plus, some services have an always free tier, or short-term trials. It's a fantastic way for you to experiment, learn the ropes, and build something without spending money up front. Really lowers the barrier to entry.
That free tier sounds like a great way to explore without commitment. Okay, so the console is the visual way in. But the source mentions other ways to interact, right? For people who maybe prefer code or automation.
Absolutely. The console is great, but it's not the only way. Depends on your workflow. The AWS command line interface, the CLI, is super powerful. It's a tool you install on your computer. Lets you control AWS services from your terminal using commands.
Ah, so scripting and automation?
Exactly. If you like the command line, it's fast, efficient, great for automating repetitive tasks.
Yeah.
The downside, there's a learning curve. You need to be comfortable with command line tools.
Sure. What else?
Then you have the AWS software development kits, or SDKs. These let you interact with AWS services directly from your application code, using language like Python, Java, Node.js, whatever you're using.
So building AWS interactions right into your app.
Precisely. It gives you maximum flexibility as a developer, but obviously requires programming knowledge.
Naturally. And wasn't there one more major one, something about code for infrastructure?
Right, AWS CloudFormation. This is infrastructure as code. Instead of clicking around in the console or running CLI commands manually, you define your entire AWS environment, servers, databases, networks, everything in a template file, like code.
Okay, interesting. So you describe what you want.
And CloudFormation figures out how to create or update it all for you. It's amazing for consistency, replicating environments, preventing manual errors. It can be a bit complex to learn initially, but it's incredibly powerful for managing infrastructure reliably.
So console for easy visual stuff, CLI for scripting, SDKs for in-app integration, and CloudFormation for infrastructure automation. Lots of options.
Yeah, you can pick the method that fits how you like to work.
Right. For me, I could see starting with the console, then maybe using the CLI once I need to automate things. That seems like a natural path. Okay, let's connect this back. We understand AWS, how to access it. Now, the core problem, our MEVN app is running nicely in Docker locally. How do we get that container onto AWS? What are the main paths there?
Okay, this is where AWS really shines for containerized apps. They have several services built just for this. There's Amazon ECS, Elastic Container Service, and EKS, Elastic Kubernetes Service. Very powerful, highly configurable container orchestration.
Kubernetes, okay. That can be complex, though.
It can be, yeah. They require a bit more management. Then there's AWS Fargate, which works with ECS and EKS, but removes the need to manage the underlying servers. Kind of serverless for containers. And Amazon Lifesail offers simpler, bundled, virtual private servers that can also run containers.
So a few different flavors depending on your needs.
Exactly. But the source material, Chapter 15, points us towards something often even simpler for getting started with a web app, like our MEVN stack, AWS App Runner.
App Runner, okay. But wait, before we deploy, don't we need somewhere to put our Docker image in the cloud?
Excellent point. Yes. Before you run the container, you need a place to store the image itself. That's where Amazon ECR, the Elastic Container Registry, comes in.
ECR, so it's like Docker Hub, but private and integrated with AWS.
Pretty much. It's a fully managed Docker Container Registry. Key features. First, security. It integrates tightly with AWS IAM identity and access management, so you control exactly who can push, upload, or download your images. It also has features like vulnerability scanning for your images, which is a big plus.
That's important. Security baked in.
Definitely. Second, scalability and reliability. It's a managed service, so AWS handles the operations, the scaling. It's designed to be highly available. You don't manage registry servers. Third, integration. It works seamlessly with the deployment services like ECS, EKS, Lambda, and importantly for us today, App Runner. Also integrates with CI/CD tools, makes the whole workflow smoother.
Okay, secure, scalable, integrated, sounds good. And cost?
Cost effective. Like much of AWS, you pay for the storage your images consume and any data transferred out. No minimum fees or upfront costs, typically.
Right. So how do you actually get your local Docker image into ECR?
It's a few steps, usually done with the AWS CLI after you've created a repository in the ECR section of the AWS console. Let's say you name your repository web app. First, you need to authenticate your Docker client with your ECR registry. There's an AWS CLI command, auth eager get login password, that handles this securely. It avoids hard coding your AWS keys.
Okay, authenticate first, critical step.
Very critical. Then you tag your local Docker image. You give it a new tag that includes your AWS account ID, the region, and the ECR repository name. Like Docker, tag my.localapp.latest, osaccounted.dtr.ecr.region.amazonos.com, webrapp.latest.
So you're pointing the image to its destination.
Exactly. And finally, you just Docker push that newly tagged image. Docker uploads it to your private ECR repository. You can then go into the AWS console, look at your web app repository in ECR, and you'll see your image listed there, usually with the latest tag, its size when it was pushed, ready to be deployed.
Got it. So create the repo, log in securely, tag the image, push the image. It's like your own secure private library for your app's blueprints.
That's a great way to put it. Highly organized, versioned, and ready for deployment.
Okay, image is safely tucked away in ECR. Now, deployment time. You mentioned AWS App Runner as a straightforward option for our MEVN stack. What makes App Runner so appealing? Especially if, you just want your code to run without fiddling with servers.
App Runner is really designed for that exact scenario. It's a fully managed service specifically for running containerized web applications and APIs. Its big appeal is simplicity. It's fully managed. This is key. AWS handles literally everything underneath: provisioning servers, patching, scaling, load balancing, monitoring. You don't touch any of that infrastructure.
Zero infrastructure management. That sounds pretty amazing.
It really is for many use cases. It has built-in container support. You just point it at your container image in ECR, and it automatically deploys and runs it. It also provides auto-scaling out of the box. It watches the traffic to your application and automatically adds or removes instances to handle the load. Keeps performance smooth and helps control costs.
Automatic scaling without configuration. Nice.
Yeah, and the deployment itself is simple. You can set it up through the console, the CLI, or SDKs with really minimal configuration compared to other services. Plus, it's integrated with other AWS services. Need a database? It can connect to Amazon RDS. Need detailed logs? It integrates with CloudWatch. It just takes away so much of the usual setup work.
Okay, you're selling me on the simplicity. So walking through it, how would you deploy our MEVN app using App Runner, pulling from that ECR image? What are the key steps in the console, maybe?
Sure. So you navigate to the App Runner service in the AWS console. You start by configuring the source and deployment. Here you choose container registry as the source.
Right, because our image is in ECR.
Exactly. Then you select Amazon ECR and browse to find or paste in the specific URI, the address of your MEVN app image in ECR. You'll also choose deployment settings. You can set it to manually deploy when you tell it to, or automatically redeploy whenever you push a new image to ECR.
Ah, automatic updates. Cool.
Yeah, handy for CI/CD.
Yeah.
Next, you configure the service settings. You give your service a name, say My MEVN app. You choose the virtual CPU and memory allocation your app needs. Start small, you can adjust later. And crucially, you set the port. Your MEVN application, built with Express.js, is likely listening on a specific port inside the container, maybe 3000, or the source uses 3080. You need to tell App Runner that port number here.
So it knows how to route traffic to the application inside the container.
Precisely. Then there are optional but useful settings. Environment variables your app needs, more detailed auto-scaling rules, health check configurations, security settings like the IAM role App Runner uses. But the basics are just source, service name, resources, and port.
Okay, that sounds surprisingly manageable. A few configuration screens pointed at the image, tell it the port. So once you hit create service or whatever the button is, how do you actually see if it worked? How do you access the running MEVN app?
That's the beauty of App Runner. Once it finishes provisioning everything, which usually takes a few minutes, it gives you a default public URL. It automatically handles HTTPS, TLS termination, all of that. You just take that URL, paste it into your web browser, and boom.
Your app should just appear.
Your MEVN application should load right up. The source material even shows the example tasks dashboard loading, proving it's live and interactive. And if something doesn't work or you just want to see what's happening, App Runner makes logging easy too. Right there on the service dashboard in the console, there are tabs for logs. You can see the application logs streaming directly. And there's usually a Vue and CloudWatch link, which takes you to Amazon CloudWatch logs for more detailed searching and analysis. No extra setup needed for basic logging.
Wow. Okay. That really is streamlined. Public URL provided, logs integrated. That's the aha moment, right? Seeing your complex MEVN app that was just running locally suddenly become a real live web service accessible globally with just, well, relatively few clicks.
Yes, it takes away so much of the traditional deployment complexity. It lets you focus on your code, not the infrastructure plumbing.
So let's wrap this up. Thinking about the whole journey for our listeners, what's the big takeaway here? We went from a local MEVN app in Docker, pushed its image to ECR, then deployed it with App Runner. What does this mean for your projects?
The core takeaway is that there's a clear, efficient path to get your containerized applications onto the cloud using AWS managed services. It shows you can achieve scalability, security, and relatively easy deployment without necessarily becoming a deep infrastructure expert, especially with services like ECR and App Runner. But maybe a final thought to leave you with. App Runner is fantastic for its simplicity. It's a great starting point. However, remember, AWS has that huge toolbox we talked about. As your application grows or your needs become more complex, don't be afraid to explore. Maybe some background tasks could run on AWS Lambda for cost savings. Perhaps you need the power of a managed relational database like Amazon RDS. Or maybe Amazon CloudFront could speed up your global content delivery even more.
Good point. Start simple, but know there's more power available when needed.
Right. And definitely look into AWS IAM for really locking down permissions, fine-grained access control. And use Amazon CloudWatch proactively for monitoring performance and costs. Keeping an eye on those things ensures your MEVN app stays robust, secure, and cost-effective as it scales.
Excellent advice. Think beyond the initial deployment, plan for growth and security. And building on that idea of exploring options, the source material also touches on other clouds. So stay tuned. Perhaps next time we'll dive into deploying containerized apps on Microsoft Azure. We'll keep digging into the world of cloud computing, trying to bring you those essential nuggets of knowledge for your next big project.